Hello, I'm Siva Balasundram. Our topic today is use of sensors in diagnosing crop stress. Remote sensing is defined as the art and science of obtaining information about an object without being in direct physical contact with the object. Hyperspectral remote sensing is one of the techniques that is becoming very popular, especially in the context of early detection of plant stress using over 100 contiguous hyperspectral bands. This approach is also called spectroscopy. Most types of biotic and abiotic stress affecting the plant in terms of nutrient deficiency and diseases that are caused by fungi, bacteria, virus, and viroid can be effectively diagnosed using spectroscopy. The concept behind spectroscopy is the measurement of reflected radiation directly or indirectly from vegetation surface. Let us now watch a demonstration to better understand what I have been talking about.
Hi, I am Kamlesh Gulhani, a PhD student in University Putra, Malaysia, Department of Agriculture Technology. In order to detect coconut kadang-kadang variety using the FieldSpec radiometer, we have to know the different components of the FieldSpec 2. FieldSpec 2 got several components, so let's see what that's a FieldSpec 2. And FieldSpec 2 we can plug using the handle, using that stripe. And let's see the different components. It's called as white reference. White reference, generally we target FieldSpec 2 toward the white reference for the optimization and collect white reference. White reference is made with a material that's given 99% reflectance of a spectrum range. And another component that's plant probe with leaf clip, and that's a halogen light for diffuse reflectance measurement in the lab, and that's a very basic important component. Its name is fiber optic cable. In my hand I have a FieldSpec 2, and FieldSpec 2 we use for measurement reflectance ranging from 325 nanometer to 1075 nanometer. And spectroradiometer I can plug like this, and I take reflectance from the fiber optic one, and then I can measure that the fluctuation of spectra in this display. There are a number of buttons like on or off, pointer, and the few buttons for management. It's called as white reference panel or spectrolon. That's made with a material that's give 100% reflectance to the spectrum. We can mount it into tripod, and we use this for taking reference before we move for taking reflectance from the vegetation. And it can be plugged like this, or we can hold like this. But it's very important to keep in a right way. A component for active remote sensing. In my hand I have a plant probe with leaf clip. In that I clip the leaf here, and I am able to take a measurement of leaf spectra. It's called as halogen lamp, and we use the halogen lamp inside the lab when we do not have ambient sunshine condition. So with the help of this active source, we can also take measurement of vegetation. That is called as fiber optic cable. Fiber optic cable consisting the different sensors fiber inside, and that's play a very major important role in a field spectroscopy. With using this field spectroradiometer, we are gonna to take reflectance from the virite infected and non-virite infected plants. In that one, we have inoculated these 15 plants from B1 to B15 with virite using the slice method. And another tray, we have 10 plants which are inoculated with a high pressure injector. And in front tray, I have 5 plants which are controlled and not inoculated with CCBD. In order to take reflectance from inoculated plant, now first I will take the reference from white reference panel, and so I will mount white reference panel to target my spectroradiometer to white reference, and there is one laser point button. So like this, it should be distance around 50 to 80 centimeter, and I will press that trigger button. So there one beep sound comes, and after that beep sound coming, one straight line comes. It shows that I have taken my reference successfully. After that, with the same height, I take measurement from the inoculated plants. For that, I put a target spectroradiometer at the plant, and I press again the button. Using with leaf clip, we attach the leaves like this and press gently, and then we are able to take measurement by pressing this right trigger. And we can try with another plant like this one. Yes. Yes, this is the result. That one curve is coming here, that's showing the reflectance between 300 to 700. That's a visual band showing the less reflectance, while 700 to 1075 nanometer you will find more reflectance. In visual region, there's more absorptions by the chlorophyll. That's why reflectance is very less. But in near infrared, the reflectance is very high.
I hope you have enjoyed the clip on the use of sensors in diagnosing crop stress. I also hope that you have gained some useful information on the application of a spectroradiometer. Thank you, and hope to see you again.